Welcome to a lesson with Dr. Powell. Let's calculate the discriminant of the powers of zeta, where zeta is a primitive pth root of unity. And we're considering this cyclotomic field where we've joined zeta to Q. And we're considering zeta's minimal polynomial, which is this right here, and p is an odd prime. Now in this video, we're going to start right here in our calculation of the discriminant. In other places or in videos that I have, we talk about the Vandermonde identity and even the discriminant of a basis in a number field. And you can look at that in the video that I have that shows that the ring of integers is Noetherian. I think I mentioned it there. But anyhow, we're starting our calculation right here with the observation that Galois conjugates or images of different automorphisms of zeta can be thought of this way because automorphisms just take zeta to another power of zeta. Okay, so we're starting here. Let's talk about how we can count pairs I less than j. This is simply just looking at the top part of an array. Where we have p minus 1 by p minus 1, and we go right above the diagonal, and this is just pairs of things that are distinct, and so it's p minus 1 choose 2, and we can calculate it this way. Okay, now all those squares that we have, we can split those squares up in as follows, where we have the ordering like I then j, then I, and in doing so we get a negative. How many negatives do we get? Well, p minus 1 choose 2, so we have that many negatives out here. We can rearrange our product, so we're going from 1 to p minus 1, so at each fixed value of I, we're looking at, because we split this up, we can write the product this way, where it can be on either side. I can be less than j, or j can be less than I, just not equal to, as we move along. Okay. Then what we have right here, okay, let's factor out zeta i's. Remember, I is fixed in this portion right here. Let's factor out zeta I, and even if we factor out of the whole product, we're going to have zeta I to the p minus 2. Where because j will be going from 1 to p minus 1, but we're eliminating one of those guys, so it's p minus 2 here outside. Then in here, notice what we're left with, 1 minus zeta to a power, and then these powers, remember j is not 0 and I is not j. These powers right here end up going through all the powers except for 1, which is this one right here. Let's see. Right, j is not right, except for this one. So all the powers from 1 to p minus 1 except for this guy. So that's going to be 1 out. But also realize that those are, if you replace the 1 with x, it's kind of like looking at all the factors of the minimal polynomial for zeta. So we can think of f of x, remembering what f of x was. This minimal polynomial right here. So it's like we're plugging 1 in. And so if we plug 1 into this, notice that if you plug 1 into f, you're just adding 1 p times here. So we just get p, and then we get this right here. So we get p over 1 minus zeta to the negative I, and that's what we get from that portion. And so we end up getting something like this coming out of that part. We get this. Now let's examine this part right here, zeta to the I times p minus 2. Notice that p minus 2 is a invertible mod p, and the exponents right here, since for zeta is a pth root of unity, and kind of we can think of these as these mod p, and notice that let's see, p minus 2 is invertible mod p, so that when you multiply it and you're going through all your i's right here, it's like you're going through all the different powers that you could have here, which mod p amount to this 1 up to p minus 1. But if you add all these up, actually, that's kind of like adding the all the lengths of all the rows in the upper part of an array, which is just, again, which is, except that this is a p by p array. If you did that, and you end up getting p choose 2. So this exponent, so as we come out and you look at the product of all these guys out here, it's going to be zeta to p choose 2, which is multiple of p. Since it's a pth root, we're going to end up just getting 1. So we can just basically ignore this part and move on. Okay, so then the product moves to the numerator and denominator. On the numerator, p to the p minus 1. The denominator, again, we use this f idea. F of 1 is equal to p. And so we're going to get p to the p minus 1 divided by p, which is just p to the p minus 2. And then, okay, so p to the p minus 2. You have this, we realize that p is odd. And so p minus 2 is also odd, so we don't really need that in this exponent. And we get that particularly this value right here is the discriminant. Thanks for watching.